Yeah, I mean, one thing I found kind of funny about your book is that it was published in March or something like that, right? Like a few months ago by now.
April, I think, in the UK, and May. Yeah, April in the UK, May in the US.
Okay. So yeah, I saw it like sometime last year then that I think you said on Twitter that you had this book on Bayes coming out or something like that. And I was like, oh, that's cool. Really looking forward to it. And then once I read it, I was like, oh, wait a minute, this is actually way more relevant to like what I'm specifically doing and the research I'm doing than I thought, because I thought it was going to be more of a, what your book is in the beginning, I guess, like the first 20-30%, like a little bit about the history, probability, Bayes' life, the little we know about him. Yeah. But then I was like, you were basically hitting through recurring themes of my podcast in the remaining.
Well, what I think of it as is, I don't know, this is going to sound grandiose, but I was hoping to help people sort of build a Bayesian way of looking at the world, not just here's a fun fact about probability and here's some history of the history of probability theory and all sort of stuff. As interesting as those things are, right? But the point was, I thought that this sort of underlying sort of structure to a lot of it, to how people learn and how we make predictions in the world and how intelligence works and all these different things and how and this sort of structure underlying it all can to a great extent be described by Bayes, and that was what I wanted to get across. Not, isn't it fun that we can the 99% accurate test will sometimes give you the wrong answer, even if because it's about the base rates, which is like the classic the Bayesian basic idea that everyone learns about it, breast cancer screening and all that sort of stuff. But to do that sort of wide angle, here is a kind of different way of looking at the world, and here's a thing that might explain huge amounts about how our brains work, or describe would be better than explain actually, but describe loads of stuff about how our brains work and how predictions of the future work and all these other things that I just said a second ago. To do that, you have to build up through what it is that probability does, why Bayes is a different perspective to frequentists, why I assume your listeners would be confident with these terms. But exactly, I think the beginning of the book is just like getting people who don't know about this stuff familiar with the ideas, and then familiar with what probability has been doing for the last few hundred years and what we want from it. And then from there, you can widen the lens and say, look, this idea that seems really simple and seems niche, and it's just really talking about, how best we work out the likelihood that you've got prostate cancer if you get a positive result on a prostate antigen test or something like that. Once you've started from there, you can expand it and you can start saying, well, actually, this is also the same structure can be applied to science. It can be applied to super forecasting. I don't know. It can be applied to the fact that it applies to formal logic is my favorite bit. And even that it's how our brains seem to work. So I loved it. But yes, it is meant to be a sort of a way of looking at the world, rather than just here's some fun stuff about statistics and probability.
Yeah, and I'm assuming we're going to hit on a lot of those parts, replication crisis, decision-making, the brain itself, throughout the conversation. I wanted to start first by going a little bit over the history of Thomas Bayes himself, the man, the little we know about him, and then probability theory. So, I mean, I think the Wikipedia, I think I counted the word count on Wikipedia of his biography, I think is something like 400 words or something like that.
Oh, it's sad.
But there's also not that much that we actually know about him. I mean, it starts with when he was born, right? And where, I think also. So can you maybe provide a brief sketch of who is the person?
Sure. Okay. So, I mean, you're right. We don't know very much about him. We know a bit about his family history. He came from a well-to-do family of his family got rich, I think, mainly selling like cutlery and stuff, like in ironworks and things in the sort of century or so before his birth. His family was also there was well-to-do middle class, upper middle class, which Britain was developing at the time in the run-up to the Industrial Revolution, I guess, and they were also nonconformists. I mean, this is crucial, right? A lot of his family were preachers in nonconformist churches. England had a civil war in the early 17th century, and in that time the religious freedom had been somewhat opened up. You no longer had to just use the Church of England prayer books. There was a little bit more freedom to dissent from the established religion. But then after the Civil War and the re-establishment of the monarchy, that was closed down a lot. So there were a lot of people who had tasted a bit of religious freedom and then it was taken away from them. And these people who wanted to become these sort of preachers weren't able to study in English universities. They often weren't, their churches weren't sanctioned by the C of E, that sort of stuff. So a lot of people, I mean, this is why people fled to the US, Puritans fleeing to the US and things. But Others stuck around and just preached they weren't massively persecuted, but they weren't hugely allowed to practice what they wanted to. So they were forced to go to Edinburgh or to the Netherlands to study and all that sort of stuff. So what that meant was a lot of their lives isn't recorded, because most of the records we have from that period are from C of E, Church of England records. So we don't actually know what year Thomas Bayes was born in. We know what year he died, and we know how old he was when he died. And I'm going to say, I think it was 1759, and he was 58, or maybe it was 1758. Yeah, I think it was 1758, and he was 50. Anyway, the point is, he was according to his biographer, with probability 0.8, born in 1700. It might have been 1701. We know that he died in April, and yeah, so you can work that out. But even those sort of basic biographical details are not known, right? We don't know much about his life. There's like the odd snippet here and there. He's got a rather longer biography by a guy called David Bellhouse, US statistician, historian of statistics, and he did a bit of a better job than the Wikipedia article seems to have done of digging out some things. So we know that there are letters to his old tutor from Edinburgh dating the time he was there, and there's letters between him and this guy, Lord Stanhope, who was a sort of very nerdy lord, obviously. He was a rich guy who gathered a sort of coterie of scientists around him and funded and backed their research. I think it was Joseph Priestley who was the discoverer of oxygen. I'm doing this off the top of my head, but I think that's right. A few others he would like fund their research and back them up. David Bellhouse said it was a bit like rich guys nowadays might back a sports team. Stanhope would back aspiring scientists and
all the way you had like court musicians and that kind of stuff.
Yeah, exactly that, or court astronomers and things. This wasn't the sort of era. It was a few hundred years after your sort of Copernicus and people and Tycho Brahe, but that's not a dissimilar idea. You're right. Hobbyist scientists getting backed by very rich people. And Bayes was himself quite well off. He had an undemanding job and family money. So we know a bit about that. Tunbridge Wells and was a preacher there. We know he was a member of the Royal Society. We know that was because he'd published nothing to do with his work on Bayes' theorem. It was to do with a work he'd published defending Newton's some work of Newton's, I think, from Bishop Berkeley.
Fluxions or whatever.
Yeah, fluxions, exactly. So which Bishop Berkeley suggested that Newton had made a divide by zero error, basically, and Bayes tightened up Newton's ideas and tried to defend it a bit more. He also wrote, and this is very dear to my heart because I did this at university a bit. He did a work of what we'd now call theodicy. So the classic bit of theological philosophy where people say, if God is perfect, if he's all-knowing, he's all-powerful, and he's all-loving, then how come there's pain in the world? And Bayes did a big piece arguing that these things always get incredibly bogged down in sort of angels dancing on the head of a pin and stuff. But he did one of them, and that got a certain amount of attention and was quite controversial, I think.
Great title also.
Yeah, oh God, it was great. Yeah. I'll see if I can find it.
Well, I've got it here.
Oh, I've got it here, yes. Oh, yeah, brilliant.
Divine benevolence, or an attempt to prove that the principal end of the divine providence and government is the happiness of his creatures.
Yes. You haven't even done half of it. Being an answer to a pamphlet entitled Divine Rectitude, or an inquiry concerning the moral perfections of the deity, with a refutation of the notions therein advanced concerning beauty and order, the reason of punishment, and the necessity of a state of trial antecedent to perfect happiness. I mean, like, I've got this really smart-ass joke in there, because his name was not on the author page, although, to be fair, there would hardly have been room. Like,
yeah, exactly.
It's spent more time writing the title than the book itself, it sounds like.
It's more like an abstract than a title, yeah.
Yes, yeah, exactly. But, yeah, those were quite... I don't think they were unheard of in his lifetime. The smart set passed these things off. He was a reviewer of a paper by a guy called Thomas Simpson, who tried to do some work into how to use statistics for inference, which is obviously what we want it for now. When we do probability, we want it to answer questions about, if we take a measurement of where a planet is in the sky from a telescope, we want to estimate where the planet is in the sky and use statistics and probability to tell us things about the world. And there was a guy, Thomas Simpson, another English mathematician, who'd started making some progress towards that, and Bayes reviewed his paper. So he was obviously involved in the intellectual life of the day. But his actual work on Bayes' theorem, which an essay towards solving a problem in the doctrine of chances, I believe it was called. I can never remember that, and I should know it off the top of my head. That was never published in his lifetime. Bellhouse, his biographer, thinks he probably didn't think that much of it because he left his papers to a friend called Richard Price, who's a fascinating guy in his own right. He left his papers to him, and he seemed to have written a will a few months before he died, so he must have known he was not well, but he likely knew that he wasn't well, and then he never made any effort to publish it, so presumably he didn't think that much of it. But yes, it was this that we now remember him for, the Richard Price published via the Royal Society after his death.
It's kind of, I find it, I mean, as you mentioned, Price is, maybe you can say a little bit about him, but it's interesting to me that, I mean, I guess it was the kind of thing where did he just get the papers or other stuff also? But I guess he must have gone through it and went like, hang on, this is kind of interesting.
Yeah, exactly. So he left Richard Price £100 in his will, which I assume was quite a lot of money at the time. And he left him all his papers, or at least a large chunk of his papers. I don't actually know if it was literally all of them. And then Richard Price, a year or so later, or a couple of years later, he's obviously, like you say, he just must have been through them. And hang on. This is, to some degree, what Bayes' paper did was what a lot of scientists, or a lot of statisticians, or I should say mathematicians, or natural philosophers, at the time, had been wanting to do, right? Maybe I'm segueing too early into sort of history of probability here, but the history of probability before that, going back to 16th century, Blaise Pascal, Pierre de Fermat, what probability had done up to there was telling you how likely you are to see some result given some hypothesis. Like the classic thing was, you've got a gambling game. To massively oversimplify, let's go for it. It's the first to 3 points. There's one person's got 2 points, one person's got one. It's a flipping coin thing, so everyone knows it's equally likely to go. Each round is equally likely to go either way. What's the fairest way to split the points? And so that's
if you have to stop.
Yeah, if you have to stop the game early, exactly. Yeah, and that's interesting. And that's sort of probability you do at school. That's how likely am I to see 3 6s on 3 rolls of a fair dice. But it is telling you how likely am I to see some result given a hypothesis about the world, that the dice are fair, that the coin is not rigged, that all this sort of stuff. And that's what probability had been. It was a huge insight to work by Fermat and Pascal to be able to work that out. And then from there, people like Jacob Bernoulli in particular sort of took that on and tried to work out things. The law of large numbers, what can we say about these different things? But what people wanted to do and what people didn't realise, what Bernoulli I don't think realised, what he hadn't worked out was that how likely you are to see some result given some state of the world is not the same as how likely some state of the world is to be true given some result. So given that the 3 dice came up 3 6s, you only see that one time in 216, what can that tell us about how likely the dice are to be loaded? It's a totally different question. And people didn't realise that for a long time.
I think the best example I think you gave was what's the probability that the Pope is human, or that a human is the Pope?
Yeah, exactly.
It's two different things.
Yeah, exactly. There's a 1 in 8 billion chance that a given human is the Pope. That is not the same as there's a 1 in 8 billion chance that the Pope is human. Yeah, exactly. So Bernoulli had been trying to do something like that. He wanted to, given that you draw this many balls out of an urn and 3 of them are white and 5 of them are black or whatever, what can we say about the contents of the urn? And he didn't realise that these two questions were different. And then people like Thomas Simpson were trying to we've got these different measurements using a telescope of some planet in the sky, and they disagree by this much. How can we average out the errors to make an estimate of where it truly is? That was Bayes who reviewed that paper and said, be aware of measurement error, basically. But Simpson had made the astute point that you should average all your results, not just using the two most extreme, which is what people did before. But anyway, these were all attempts to start using statistics and probability to say things about the world, and it was Bayes who had the insight that you need to have prior probabilities, that you need to bring in stuff you knew in the past. You have to use all the information available to you, basically, to do that. And it's interesting to me that he didn't realise, or he seemingly didn't realise what a massive deal that was, because he was involved in all this. He was so involved in the thinking about probability. He'd obviously read Abraham de Moivre's book about normal distributions and all this sort of stuff, and he'd been in conversation with Simpson, so he must have known about this effort to work out how to make inferential statements as opposed to just ones about what we'd expect to see. But he didn't make the leap, and it was Price who, like we hinted at, he's fascinating. He's another nonconformist preacher who was like friends with like half of the founding fathers of the American Revolution. Like, it's such a cool, it's amazing sort of insight into how small the intellectual world was of the day, I think. But he's exchanging letters with Benjamin Franklin and Thomas Jefferson. He wrote a pamphlet which was credited with inspiring a lot of the work of inspiring the American Declaration of Independence. And it's funny, you don't really hear his name that much these days. Or at least I didn't much before, apart from as the guy who published Bayes' paper.
I didn't know about him either.
No, exactly. I found that really interesting. So it's fascinating to me how Bayes didn't make this connection. That I've answered such a huge question here, or if he didn't make a big song and dance of it, and then he just died, and it was left to Price to work it out.
Two interesting things I find there. One is that, I think in general, it's often not entirely clear to people creating something how important what they're doing is going to be. I think that stuff often only takes a few decades or sometimes centuries for even the world to recognize actually what's going on there, how useful something is.
Yeah.
But what I also found kind of interesting about the history of probability theory is that, once I might have read something a little bit about it, but pretty much most of what I know is from your book. And it seems to me that people weren't thinking about probability, at least in a formal way, until really late. I mean, like for some stuff like calculus, you can kind of understand why it might take a little bit. But probability, I guess, is something that we use so much in everyday life today, the way we talk about events and that kind of stuff. And I don't know whether... Do you know, were they thinking about it, but just they hadn't formalized it, or was it, I don't know.
They were thinking about it before Fermat and Pascal. People had been trying to work out things like how come, what was the classic thing? It was how come the chance of seeing 1/6 on 4 rolls of a dice or 4 rolls of a die, I should say, on 4 dice, is different from seeing a double 6 on 24 rolls of a pair of dice. People say, well, they're the same sort of relations to each other. Surely it should be the same thing, but actually they're very different. And people were puzzled about why this was different. It's called. I can't remember. I don't think there was a particular name for it. But yeah, there was this guy Cardano who was trying to work out those particular problems years before, and people were getting what seemed to us now like comically stupid errors. Like a guy who wrote some groundbreaking mathematical textbooks, Giacomo Cardano, I think his name was. Girolamo, Cardano. And he was asking about what's the odds of rolling a 6 on 4 rolls of a die. And he thought it would be 4 times the chance of rolling a 6 on 1 die. So it'd be 4 in 6. But that's, even if, I find that baffling, because even thinking about it for a second, well, hang on, wouldn't that mean it would be certain to see it on 6 rolls of a die? But that's obviously not true. That can't be true. So,
and from experience, he must have known that.
Yeah, it's fascinating to me. But it does suggest that there wasn't just like some basic breakthroughs, some sort of real sort of perspective shifts needed to happen before people could make this work. And the fact that it just wasn't there in people's heads. And Pascal and Fermat did manage those breakthroughs. But then... yeah, it was still a long way to go. There was still, and that was only, as I was saying a minute ago, that was only working things out that would help you if you're gambling, or like it's a sort of insight that lets you work out the chance of seeing like a full house in poker, given that you've just drawn an ace and a jack, or you've just drawn a pair or something like that. Stuff that's interesting if you're in a casino, but it's not inherently useful if you want to do inferential sort of science about the world, which I'm sure from a fairly early point must have been what people wanted. People are at that point just, it's the Renaissance. People are just getting interested in science. They're starting to do these measurements of the world. They're seeing this particular light in the sky has shifted this far. And we're just coming to grips with, I guess, the heliocentric model of the solar system. We're trying to work out all these things. And at that point, it must have been really useful to start doing statistics and probability on how likely things are to be in different places and all that. But the conceptual sort of shifts, the conceptual sort of insights hadn't happened by then, and it was really being pieced together for over centuries,
Yeah, I mean, what I also find interesting is that, this is also one of those things that I've read somewhere once, and it was a while ago, so I don't quite remember this, but that I think it took pretty long. I mean, I think like some aspects of mathematics were well developed, like geometry and that kind of stuff. I think that a lot of that was developed Euclidean geometry at least, was developed fairly early, but that I once saw something about the history of mathematics where they showed how mathematics was done in the Middle Ages, and they hadn't figured out the whole way of having equations for stuff. Like they were writing everything out in sentences. And so I wonder like whether maybe like, you know, I guess Newton was a bit before that. I don't know exactly when this happened, but I mean, that must have had something to do with them getting a lot better, a lot of these kind of abstract quantitative things.
It is. I mean, you can see it in I looked at some of the original papers. I found scans of them online, and they write things out longhand an awful lot. Which, you know, and there's old Pascal and Fermat people saying things like, if I win, I shall gain all, that is 64. If I lose, 48 will legitimately belong to me. He's writing out, whereas write whole paragraphs of text to explain something that a modern mathematician would do in probably 8 symbols. Yeah. Just I'll do a larger than and then a little dot over some number or something. It'll just like, we now all understand what this means. Can we move on? It's actually really useful for me as a non-mathematician, because I can follow the concepts when they're written out, but I don't I see like a sigma sign and my brain freezes up. Oh God! But
that's going to be a new application for AI, translating current mathematics into middle-aged writing.
Yes, yes, exactly. Write this out like Blaise Pascal would, and I'll be able to understand it, but not in French, not in like early modern French. Yeah.
I was about to say it's not even French. Yeah. So maybe to go back to continuing the history. So Price publishes this. I think if I remember correctly, you also said with a lot of additional stuff that Price added of examples, I believe. Or something like
absolutely. So Bayes' original stuff was pure theoretical maths. It was just, he imagined someone... There was a specific example was someone rolls a white ball on a table, and he doesn't say a billiards table or a pool table because he's a very serious and godly man, a nonconformist preacher, but it obviously means a billiards table. The ball bounces up and down and lands somewhere at random. You take the ball off, but draw a line on the table somewhere at the point where the ball ended up, across the table. And then you continue, then you throw more balls onto the table, rolling them up and down, and the person... or rather, someone does this and they tell you about it. They only tell you whether the balls land left or right of the line. And your job is to do your best guess with the information given to you where the line is, and therefore the probability that the next ball will land either left or right of it. And that's the fundamental. But Bayes' big insight was if they throw 5 balls and 3 of them end up left and 2 of them end up right, your best guess is not the white line is 3/5 of the line at the table, but because you have to take into account your prior probability, which is that the ball could be anywhere. You have no prior information about where it could be, so you have to assume that it could be randomly anywhere. And so then the way he did that was, you say, imagine basically there's an extra ball on either side of the line. So instead of saying your chance that the next one will land left is 3 out of 5, you say it's 4 out of 7. So the number that you had plus 1, the number left plus 1 divided by the total number plus 2. Don't worry too much if people aren't following that, but it's just saying you have to add a sort of bit of information to say that I have some prior information about this. And it was, it's an interesting theoretical result, but it was Price, who, one historian of statistics, I think describes him as the first Bayesian, so the first person to use Bayes' insight on practical applications. And he, doing the same sort of thing, like, can we use this to estimate how likely we would say it is that the sun will come up tomorrow, given that we've seen it X times? And it's the same thing. I've seen the sun come up 1,000,000 times, but I can never be certain it'll come the next day. So we have to do the same thing of saying, adding 1 to the didn't happen stage and adding 1 to the did happen stage. So instead of saying the next chance that the sun will come up tomorrow is 1,000,000 in 1,000,000, absolute certainty, instead it's 1,000,001 in 1,000,002. So it's near certainty, but you never quite get to actual certainty. You keep pushing it further, pushing it closer and closer. But he also wanted to do it to show that exact point that you never get to certainty. He wanted to use it as a sort of a hedge against, or like a defense of God against David Hume. And I really enjoy this. David Hume, obviously a great atheist philosopher of the era, and by all accounts, really lovely, affable, charming guy. But he'd written this thing saying, which in itself, when you think about it, is quite Bayesian, right? He said, I can't remember the quote, but it was people tell you that if someone says to you that someone came back to life after dying, you have to say, like, okay, what's more likely that actually happened, or that this person is lying or mistaken? And then he's saying, evidence of miracles, accounts of miracles you hear, to believe them, you have to say it's be even more unlikely that the person telling about them is wrong than that the miracle occurred. So it's actually, so he's saying my priors of these things not happening are so strong that almost no amount of evidence will overturn them. Price's point was you can never be certain. The fact that you've seen people not coming back to life a million times doesn't mean that the million first time they won't. And these are both true facts about when we look at the world through a Bayesian lens. It is true you never reach certainty, but it is also true that that very confident predictions, such as people don't come back from the dead, need a lot more evidence to overturn them. So both men are just taking different angles of the same of Bayes' theorem, I guess, to look at it. But it's quite nice because they had this sort of exchange. But Price was quite uncharitable about Hume and said all this like it's specious and all sort of stuff. And then Hume wrote to him and said, "Oh, I see your point," and all sort of stuff. And then you see Price going, "Oh, actually, I feel a bit bad about this. I've been rude and changing it." And so said, "You've been you've been really polite and thank you." And they had a really lovely exchange on the whole thing, which I always quite like. People disagreeing about something really important and major, like does God exist, and still able to have a civil discussion about it. Although it was great.
Yeah, this is something great about someone being kind of vicious and the other person being really kind, and then the completely first person feeling like, oh, shit.
Yeah, exactly. Completely undercutting them. Yeah, I feel like a right bastard now.
Shouldn't have done that.
Yeah. But that's the first. It was the first half of the paper, an essay towards solving a problem in the doctrine of chances. I'm pretty sure that's what it's called. And the first half of the paper is all Bayes. It's all theoretical, it's all very sort of ivory tower stuff, and the second half is all Price, and it's all the applied things, and it's basically him trying to say, no, actually, miracles could happen. You, David Hume, and so it starts out from the beginning of having quite lofty applications. I think it's fair to say.
Yeah, definitely. The application is a lot more important.
Yeah.
Than many other stuff. So this was then, I guess, what would this have been, like late 18th century, something like that?
Mid 1765, something like that.
And then, so what happens then for the next? I know the Pearson of these people were like 1900 or something like that.
Yeah. Well, so what happened? I mean, a lot of things happened, obviously. Firstly,
in the world of statistics and probability.
Yeah. But exactly. Yeah. Then there was the Napoleonic Wars. Well, for a start, the idea of this sort of this inverse probability, as it came to be known, the idea of probability that tells you how likely something is to be true given some data, rather than just how likely you are to see some data given that something is true. That was independently discovered by Laplace a decade or so later, and it would have had his name on it had luckily Price not gone to Paris and met Laplace's I want to say PhD supervisor, but that's obviously not right. That's massively anachronistic. Sort of equivalent, some sort of his
mentor.
Yeah, mentor. Yeah, and I think it was Le Condorcet or someone like that. He said, oh God, yeah, this is exactly what Laplace has said, and so therefore by law of sort of priority, this should be Bayes' theorem, not Laplace's theorem. Laplace, very gentlemanly fashion, went, yep, no, you're right. Even though I think by all accounts, Laplace is the one who's done the better treatment of it, gone into more detail, not just dashed it off as an afterthought and then died. But
it seemed to be very generous on. That's just, I guess, his view. Bayes was first, but I was a little bit surprised, like when you in your book when you get to that point, and he's like, he just accepted it. And you're like, oh,
yeah, okay. No, that's the rule, right? And you go, oh,
yeah,
I suppose, oh shit, oh bollocks. But
yeah. People always have fears of being scooped in science, and man, that must have really bit. That one must have stung.
Yeah, exactly.
I guess Laplace has his name in the history of mathematics. He's fine.
It's not as if we don't remember who Laplace is. But yeah, so it was rediscovered, and it became. I think it was on its way to becoming quite a big deal. And I'm slightly cribbing from the history of a guy called Aubrey Clayton here, who is nakedly a Bayesian partisan, right? He had his line in his own book, which was that lots of people trying to end the stats wars between Bayesians and frequentists. I am not trying to do that. I'm trying to win the war. So he got some brilliant line, like, consider this book propaganda to be dropped from planes over enemy territory. At least you're sort of really open about this. I found it quite refreshing. But he said, like, a lot of what happened after that was that people didn't. I suppose the big thing, which we haven't said really about Bayes' theorem, is that the implication of it is that probability is subjective. You know what I mean? Mm-hmm. Probability is, it's not some true fact about the world. It's not like we can say if this coin were flipped an infinite number of times, it would come up heads half the time, whatever. We are saying my best guess about how this coin will come up is 50-50 because I haven't got enough information to do better. And all probability estimates are, to at least some degree, subjective best guesses of how likely things are to be. how likely things are to happen. And that's really uncomfortable. That a lot of people don't like that at all. They still don't. They didn't at the time. And I think a lot of people wanted to say that no, science is objective. There is a true number, which is this is how likely this scientific hypothesis is to be true or whatever. And that is just not within the gift of Bayes' theorem. It's not within the gift of anything, to be clear. You can't do that. But there's something feels more sort of rock solid if we're saying these are actually the chance of seeing this result given the null hypothesis, and therefore you can just say this is objective truth. I mean, of course, even that's not completely true either. Yeah. But it has this sort of veneer of objectivity which Bayes' theorem doesn't. So I think that a lot of people got uncomfortable with that. In the people kept trying to apply these sort of measurement techniques and statistical techniques to social science in the years afterwards. And I think a lot of, for various reasons, I mean, Clayton's claim is that it's a lot to do with people wanted it to back up racist claims about which different races are better and all this sort of stuff. And they can just say, we've got, the numbers are objective and say this. I don't buy that. I really like Clayton's work. I think it's really interesting. That particular, it felt very inflammatory. And I bet if the history of science had gone the other way, I'm sure there'd have been lots of Bayesians you could justify the finding of the claim that Bayesians were more racist because it's just people were racist then, right? And the establishment was
and they were trying to find stuff out, and
exactly,
all sorts of stuff and use whatever they had.
So I mean, I was speaking to a Bayesian statistician after the book was published, and he was saying, well, firstly, you can't judge which framework of statistics is best by who had the most unpleasant adherence. And secondly, it's not as if Bruno De Finetti, who was a great... he's dead, so I think I can say this without libel. But I think he was a member of the Italian fascists. He was one of the great pioneers of Bayes' theorem and all that sort of stuff. So there's just... I didn't feel it was worth... I don't think there's any real sort of mileage in there, and that it was... Frequentism is designed as a cover for scientific racism. But... It is true that a lot of the people who followed it did, and then but also people did want to be able to say, this is just objectively true. This is what we have seen, and we don't. There's something squishy and unpleasant about saying, I'm not going to publish this scientific result because I didn't believe it was very likely in the first place. That's the problem, right? That's where it gets squishy, and I think people didn't like that then. They don't like it now.
Yeah, I mean, it's still that in science, I think you still kind of have the sense of trying to find out how things actually are. I feel like that's inbuilt into the whole proceeding, that you don't go, okay, I'm trying to create... I mean, in a way, you're creating models that predict some data, or you're collecting data to test the model, or both. But it does seem to me that you are trying to find some sort of objective truth that's out there in the world to explore. And I can understand that. I mean, especially maybe we'll get into a little bit later the whole problem of the prior invasions and how you select that. But I mean, I guess the whole thing is that, like, I would imagine it's just very uncomfortable if changing the prior can potentially change quite a bit about the results.
Exactly. That is definitely uncomfortable. I mean, to be clear, right? Subjective doesn't mean made up. It doesn't mean equally good. You can. The example I often give is if we were gambling on the roll of a dice, and I said, well, my prior is that this dice is 5 times out of 6, this dice will come up 6, and your prior was 1 time in 6, and then both of us would be rational to bet at evens on it not coming up, on you saying it won't and me saying it will. But under most circumstances, your prior is better than my prior. You will make more money than I will on that bet, and these models are better and worse insofar as they better predict the world. It's the old George Box, another great Bayesian, George Box, who said all models are wrong, but some are useful. And all these models of the world, I mean, even down to quantum mechanics or relativity, to some extent, they are just mathematical predictions of the world, which you and I would probably say are getting closer and closer to describing the underlying reality, but they are not the underlying reality. The map is not the territory. And whether or not we'll ever say, yes, we have now perfectly mapped out what reality is, I'd be a little surprised if there's ever just a point where we stop like that. Maybe there will be. But even so, we've made a model that we can't improve on, and it perfectly predicts all our data, so therefore we can say this is as good a model as we're going to get. Like, I think that would probably be where I imagine would end up. And then I would also be happy to say, and I bet it's extremely close to a fundamental underlying reality, but I won't be able to ever prove that. You know.
Yeah, it must be a weird moment when you're doing your science and suddenly you're like, wait a minute, I think we're finished.
Yeah, exactly. Pack it up, guys.
Okay, that was, oh my God, got to find a new job now.
Yeah, exactly. It's been a good 2,000 years, guys, but we can all go home now.
Yeah, but as you said, I mean, or not as you said, but to add to that, I think I'm assuming Newton's model was thought of as being perfect for centuries. And then Einstein came along and said, well, not always, but Newton's model is still very useful. Yeah, I mean, so like it's not like it's thrown away.
No, exactly. Well, it still tells you when the next eclipse will be on the continental United States or whatever. You can still say, I can predict a solar eclipse in Minnesota in the year 6000 AD or something. And it's still, I mean, I think I'm right in saying they don't bother with relativistic predictions when you're slingshotting a solar probe around Venus. You just say the Newtonian physics does you perfectly well for that. And again, for very high speeds and very long way out. It's only when you get up at not far off the speed of light that it really starts to matter. It does matter when you're doing GPS satellites, doesn't it? Because they actually need to be down to tiny fractions of a second to do their syncing with other satellites and with your position. Otherwise, you end up slightly drifting off your position, and people start driving into the North Sea when they use Google Maps and things. But
well, I think they can also use perfect GPSs to do that.
Yeah, well, that's also true. Yeah, but the model that is Newtonian physics is astonishingly accurate and remains so, even if there are tiny bit more accurate ones that work better at very high speeds and incredible temperatures or very large masses, whatever the different things are.
Yeah, and what is useful depends really on the context.
Yeah, what you want it to do.
Yeah. I had just because I found this amusing. You had, when you talk a little bit about when Bayesianism or Bayesian statistics at least became more popular again, at least in some circles in the 20th century. You mentioned quite a few Bayesian songs.
Oh yeah.
So if you want, feel free to sing a few. Otherwise you can describe what was going on there.
Yeah, I'm not sure anyone wants to hear me singing. There's no business. There's no theorem like Bayes' theorem. There were some great ones. Do I dare? But mine eyes have seen the glory of the Reverend Thomas Bayes and all that sort of stuff. That's as much as I'm going to do, because my wife ever hears me. My kids, they're going to murder me.
Nice.
Thank you. Yeah.
I didn't think you were going to sing any of it. No, that was more than I hoped for.
Yeah. But it's brilliant. Bayesians get accused of being a cult, and I do sometimes think that maybe if they didn't have a literal songbook about "Mine eyes have seen the glory," that would have probably helped them.
Yeah.
But it was. That was great. There were these. So in the 1970s, late 70s, Bayesianism basically got sidelined after. In the late 19th, early 20th century, the sort of giants of statistics were Francis Galton and then Carl Pearson, the guy Neyman, whose first name escapes me.
Yeah, and Jerzy or something.
Yeah, exactly.
Polish or something.
You're right, Jerzy, something like that. And Ronald Fisher. And they hated Bayes. Fisher described it as the greatest mistake that science has ever committed itself to, or something like that. Fisher and Pearson had a longer than lifelong falling out when Pearson misunderstood. So Fisher came up with what we now know as the likelihood estimate, which is half of the Bayes equation, basically. It's working out how much more likely you'll be to see some result under one hypothesis than the other, which is what you need to do to work out Bayes, but you also need to do full Bayes, you need the prior as well. Pearson misunderstood what he had done, thought that he was assuming they were including a prior, and that he was assuming everything would be equally likely, and he was just saying, this is an error. But he's basically accused him of Bayesianism. Fisher hated being accused of Bayes so much that they fell out, never talked again, and Fisher maintained a feud with not only Pearson but also his son for years afterwards, despite them both being given they were sharing Pearson's chair of they were the chair of the professor of eugenics at UCL. Interesting little detail. UCL used to have a chair of eugenics, but anyway, there we go.
Also, just for context, Pearson's son was also a statistician.
Yes.
He wasn't just randomly attacking Pearson's son.
Yeah. He was also, but that's so because Fisher and Pearson's son ended up sharing that UCL chair. But yes, that is an important detail. I agree. So I don't think it's overstating the case to say that Fisher and Neyman and Pearson invented what we think of as modern statistics. There's the Fisherian school of frequentist statistics and the Neyman-Pearson school. And they all just utterly rejected Bayesianism. And all the things people use to do statistics now, like p-values, statistical significance, likelihood estimates, ANOVA, all that sort of stuff. It's almost all Fisher, really. And that just squeezed Bayes out completely. But for the sort of 50 years or more between Fisher doing all this in the early 1900s and Bayes becoming more mainstream in the sort of the revival of Bayesianism again in the sort of 70s, people kept reinventing it, sort of because it was useful. Like, it's actually, if you want to do inferential probability, you need Bayes. So what's his face? Alan Turing invented something very Bayesian to do inference of how likely when they're working out the signals from the Enigma machines, you had to use some sort of assume that some string of letters was more likely to read ein in German rather than some random JQX, whatever. And so he needed that. So he did. He reinvented Bayesianism. People kept using it for other. I remember speaking to one statistician who said like he went to Silicon Valley and met some friend who said who worked out a way of estimating I can't remember exactly what the software he was doing was, but it's just like he's just reinvented Bayesianism. And tech, a lot of people are doing this a lot, and other areas as well. And then, what was his name? Harold Jeffreys was involved in a big argument in the sort of 30s, I guess, with Fisher about he was a geologist, and it was useful to him to use prior data because he didn't have that much data when you're studying how waves propagate through the earth, and you've only got occasional earthquakes to try and measure them, and not very good. So it was useful to use Bayes where you're allowed to use pre-existing data, whereas under frequentist systems, you have to throw away all previous data and pretend each test is on its own. So Jeffreys was a big fan of that, and he had a lengthy debate with Fisher about it in the pages of some scientific journal or other. The debate was inconclusive by all accounts, but Fisher won, as in we still use Fisher stuff. But then in the 70s, and this brings us back into the songbook, someone had I spoke to this former president of the Royal Statistical Society, a guy called Andy Grieve, and he said that whenever I used to turn up at statistical conferences, they'd like give the Bayesians the joke slot, like the before lunch slot. As here's Andy to talk about Bayes. Way everyone. And then they did a conference in, I can't remember where it was, I think in France somewhere, and it was just Bayesians. And everyone it's quite nice this. I don't have to like defend Bayesianism against everyone. Like I don't have to end up being treated like a comedy afterthought. So this is fun. And so they started setting up more in Valencia quite regularly, and then a few other places as well. And it sounded like carnage. Like they just got hammered, and they were like they were saying like they all have a siesta in the afternoon and start working again at 6 p.m. and then at 10 o'clock they'd all go to these parties in the evening where they all like karaoke. And they were singing Bayes-inspired song, Like a Bayesian, to the tune of Like a Virgin, that one I just sang you. Bayesians in the Night, to the tune of Strangers in the Night. Professor David Spiegelhalter, another former president of the Royal Statistical Society, he tweeted at me, he's a good lad, he tweeted at me saying, our performance of the full Monte Carlo was before the smartphone era, so no recordings exist. And so there was sort of six male professors of Bayesian statistics taking their clothes off in front of a screaming crowd in a Spanish nightclub. It sounds brilliant. Anyway, there was lots of fun.
That's what happens once the Bayesians are freed from having to justify themselves.
Yeah.
I guess we've kind of gone through like the first, 2-3 chapters in your book now, something like that. And the remainder are specific applications. And I guess to pick one out, the one that actually surprised me almost the most, I mean, not really surprised me per se, but it did surprise me a little bit to see that as the first application you mentioned was with the replication crisis, because I mean, to me, like decision theory and Bayesian brain is like super obvious that it's just all over it. And one is in the name. Yeah. The replication crisis for me, and the stuff I've done on my podcast so far about it has usually been stuff about, trying to replicate results and pre-registration and all these kind of things. But I hadn't really done actually that much about this aspect that you mentioned and how the replication crisis could be improved. So maybe if you could kind of briefly start with a topic actually I've already discussed with your friend Stuart Ritchie. Yep. I initially talked about I think the first minute of my interview with him is me mentioning that it's too long. Anyway, it's too long, but it's exactly about the BEM stuff. It's basically the first minute of our podcast. So maybe if you could just describe kind of briefly 2011 stuff that was happening in that year and how kind of the Bayesian statistics kind of then offers some sort of help or solution.
Yeah, I mean, I don't want to claim that Bayes statistics would solve the replication crisis.
Yeah,
Exactly. Like that. But so 2011 was a big year in science. Although I was a science journalist at the time, or at least writing a lot about science, and I didn't know for 2 or 3 years afterwards. But there were various things. There was a Diederik Stapel fraud case, in which it turned out the sort of up and coming star of social science psychology, I think, social psychology. He basically been making up his results, and completely out of whole cloth. And lots of these quite famous results of his just were based on nothing. Not
bad. Just like tampering with data, but actually just making it up.
Yeah, sitting at home with a glass of wine, apparently, filling in the spreadsheets.
Typing it in.
Yeah. And that was bad, but I guess fraud happens, right? It's bad because you don't want people to be fraudsters, but it's not as. It's sort of it's priced in to an extent. People sometimes are bad actors. And you hope you weed them out, but basically some people are just cheats, right?
Yeah, there's always going to be crimes.
Yeah, exactly. But what was worse in a way was the same year there were 2 papers released which couldn't be true, really, unless something was totally different about how the world worked. The result they found couldn't be true, couldn't be real, unless everything we understood about the world was wrong. And yet they were both proved, they showed to the level of statistical sort of satisfaction that there's enough to get most things published. And they seemed to use perfectly normal statistical techniques. So the one with Daryl Bem, who you discussed with Stuart, I gather, and he did a study called Feeling the Future, which, I mean, without going into too much detail, seemed to show that people were psychic. And it found with very low p-values, very to extraordinary, to the same levels of statistical significance that we would be happy to use in other situations, and using the same statistical techniques, it showed apparently that people were psychic. So that was one problem. The other one was, and that was an honest, serious paper. The other one was a sort of satirical joke but serious point paper called False Positive Psychology, and it found, I mean, among various other things, that people who listened to When I'm 64 by the Beatles became younger. Not like they felt younger, but their birthday became more recent than people who listened to a Control song, which for 90s music fans was Kalimba by Mr. Scruff. And obviously that logically cannot be true. I suppose it is logically possible that psychic powers might be real, but it is logically impossible that people's birthday could get nearer. I think that is a fair thing to say. So that really threw people, and people were sort of like, well, what's going on? And it turns out people had been using very small sample sizes. They hadn't been pre-registering. One crucial thing was that you could stop, you could do multiple tests and then pick the one that finds something. You could stop your data collection whenever you see that it's dropped below p-value, a given p-value, and then say, okay, I'll stop there. And these things were easy ways of getting low p-values, apparently surprising results out of basically noise. And yeah, you'll have discussed, like you said, you've discussed a lot of this in other situations. I'm a big fan of things like registered reports and pre-registration for ways of limiting this. But there are ways in which not being Bayesian in this situation can be harmful. I really want to be careful about overstating it as some sort of panacea, because I don't think that's true. But I mean, for a start, on the very specific problem of optional stopping, where you're gathering data and you can just decide to say, I'll stop now, and look, it's my p-value's dropped to 0.049, stop immediately. That doesn't matter in Bayes' theorem, because each new bit of data is added to the data you already have, and so it actually, optional stopping is a good thing in Bayes' theorem. But that's quite a niche
good
case.
Because it's more data efficient, right?
It's more data efficient. You can, if you've got to a point where you're confident that your cancer drug or your vaccine works, you don't have to keep plugging away to the end of the trial. You can get it into publication, get it into production faster. So that is a good thing. There's also a point that, because like we've discussed, under frequentist models, frequentists will probably tell me there's more to it than this, but you do kind of have to throw away all your previous data unless you're doing a meta-analysis. If you're saying, this new study I've done, we ignore everything that's gone before, and if it gets it below 0.05 p-value or whatever is your threshold, we will treat it as though it's real. But that privilege is in combination with the problems that we have with scientific publishing. People want novelty, and that scientists are driven to get things published because otherwise they won't progress in their career. The publish or perish model of academic careers, and also the demand for novelty in scientific publications, combined to people are incentivized to try and get papers into journals, even if the findings aren't real, and in order to do that, they will have to find novel, exciting results. And the novel, exciting results. If any less than 1 in 20 coincidence is enough to count as a novel, exciting result, then you are incentivized to go and look at really unlikely things and hope that you get a freak result. So like
the kind of thing that's really surprising.
Yeah. If you did like a study into do hammers fall faster than helium balloons, then you could get you just drop a hammer and a helium balloon at the same time. You do that 6 times, I think. You get a p less than 0.05 result if the hammers crash to the ground each time and the balloon floats up. But you say, look, I've got this, but I don't care. Obviously, that happens, right? But if you got someone to guess 6 coin flips in a row and say that would only happen one time in less than one time in 20, that's statistically significant. Therefore, this guy's psychic. That's much more exciting and impressive, and that would be, in theory, obviously it's not how it works. It's obviously a cartoonish like depiction of it, but I think it still makes the point that usually it's not that obvious that it's a silly question, and there's obviously more to it. But it privileges silly questions, and a virtuous frequentist would say, I'm only going to research things I believe to be true because they use prior information about what they know about the world to guide them to research questions that they think are likely to be true. But if you're unscrupulous or you're desperate to get it public, then you are incentivized to go and fish for outlying results. And then you get all of the priming studies of like people saying, putting them in a room with a room that smells fishy and see if they act more suspicious when they're in a room because it smells fishy. And you get people getting those results. And that is not, I don't think that's very likely to be true, to be like a real underlying replicable finding, but it ticks the counterintuitive box and this is exciting. And if you did 20 studies like that, on average, you get 1 freak result, and then you take it to nature and say, look, So I think there is an element of frequentist model that does overprivilege these freak results or silly questions. On the other hand, a frequentist would say, and frequentist did say, Daniel Larkins, who's a very strident frequentist, but I think a very bright guy, and obviously understands that you need Bayesianism to do estimates of how likely something is to be true. But he says, I don't want dogma in science. He says, sure, you publish, you should do your research well, you should pre-register your results, you should do all these things. But if a surprising result comes in, you shouldn't say, well, I don't think that's very likely, I'm just going to sit on it. So it is not a clear cut, I'm not coming down as pure Bayesianism as the answer for everything, but it would solve certain problems and I think it's also just aesthetically neater and includes a lot more of the system. You don't have to like keep bolting on new methods to do stuff. It includes the whole data analysis by itself. It is its own meta-analysis for a start a lot of the time. So I think it's a lot neater and more elegant. But it wouldn't be without its own problems. And one of them is you have to be careful about, I'm sure we'll discuss, where you get your priors from. Are your priors going to influence your result? Do you say, I think this is like 99.999% likely to be true, and therefore whatever data I brought in doesn't really matter? That you need to be careful and guarded against that sort of problem.
Yeah, I mean, I've not yet done a lot of Bayesian statistics myself, or almost none. But to me, that always seems like just the big questions. What is, especially if you have, let's say, you combine a few studies. Often papers are multiple experiments that aren't exactly the same. Yeah. They're not perfect replication of each other. So for me, it's really, as someone who's still on the outside of that and hasn't done it practically himself, it always seems like that's just such a big, somewhat arbitrary plucking a number out of thin air of whether it's 0.1 or 0.001 or 0.5. Like,
I mean, it's a problem. It's not a silly thing to worry about. Speaking to the Bayesians who did this, they were like, if you're doing it in pharma, depending on where you're doing it, you use pre-existing, there usually is data from earlier studies. And that's why I was saying, like, there's the meta-analytic prior you can actually you gather up the data from previous studies, you put them into a meta-analysis basically, and then you say this is our starting prior for the new ones, and you use, and that is a good point and a good way of doing it. There's also, I speak to one guy who's working I can't remember his exact. He's looking at fishing techniques in the developing world or something. I can't remember exactly. I don't know how you describe what he did, but anyway, he was saying you can look at. That you just use data, but then if someone comes up to you and says, "No one in this part of the world will ever do that thing you're talking about there," he says, "It's not data, but it feels mad not to use that information to not use it somewhat to downweight your prior." So yes, it is arbitrary and subjective, but it does need to be done. The other thing is that someone else pointed out, Eric Jan Wagenmakers, He said, like, you can crowdsource, like get people to, does this prior seem reasonable to you? And if someone says, no, you put it as 99.999% likely that psychic powers exist, I don't buy it. You can crowdsource and double check, but also you can check the robustness of your results. Like, what if I'd used a different level of prior? And if you've got reasonably good data, then to some extent it should wash out your priors effectively anyway. If otherwise it sounds like your data is pretty rubbish. So, but then you might reasonably say, well, in which case, what's the point in having the priors in the first place? So,
it does. I think in part it's also, I think, just good modeling practice where you try and test your results over a range of parameter values, basically, to see how it affects it. I mean, I think that is actually a very good point. That just see what would happen is basically not like to see basically like how dependent are your final results on the initial prior you
exactly had. Just a robustness check, right? If that doesn't, and if it completely changes everything, maybe my data was a bit rubbish. Maybe we should be less confident in this, and maybe I'm over relying on my priors. But there are principled ways of getting priors. I mean, there's a whole thing called that Jeffries tried to set up called objective Bayesianism, which was trying to do this in a more objective way. Obviously, they didn't really manage objectiveness, obviously, because none of us can objectivity, I should say, but they made a more principled way of putting systems in place for getting priors that aren't just, I pulled this one out of my arse, what are you going to do about it?
I think the general problem is just that there's so many things that are basically impossible to quantify when doing science that it almost feels pointless. Even if you do a meta-analysis, is this study is probably going to has maybe an obviously better methodology than another study. But like, how much better? Then would you want to quantify that into it? And there's like,
how much do you weight your studies? That's exactly.
I mean, you can do it by number of people, but if one study is way better than the other, then is that even important that there's lots of people in it? And so I mean, I probably will at some point start looking into this myself and actually doing it and using it. So we'll see how I
think that it strikes me that there are definite uses for it, and I think in some places it improves inference, and I think it has a neatness to it. But I'm just some guy who writes. I'm a journalist. In the end, don't take statistical advice off me, and if you're in any way someone who actually works with these things for a living, you'll be able to read the equations in a way that I usually can't. So if you find things work fine with frequentist methods and you're finding out true things, then great, more power to you.
We should maybe highlight, this is not a textbook.
Yes, exactly.
Yes, before we get to the recurring questions, I just had a few questions basically about you, how you got to do this. I mean, it seems to me you studied philosophy, I believe. I found it somewhere on some website. It was a bit hidden, but I got it. And something about medical law and ethics. Yeah,
so I did philosophy undergraduate at Liverpool University, which I strongly recommend northern campus universities to anyone who wants to northern, because it's just a lot of fun. Anyway, I had a great time, but then went to King's College London to do a master's degree at what is called their Centre for Medical Law and Ethics, but it was more philosophy. It was under and then after my master's, I tried to do a PhD, to complete lack of success. Had no idea what I was doing, but it would have been a PhD in the ethics of science journalism. But I hadn't worked a single day as a journalist. I didn't know what I was talking about. It's like being a lepidopterist who's never seen a butterfly. It was just a lot of me trying to prove that my prejudices were ethical, but it was many such cases.
I was about to say that's right. But sorry, was this, so you started a PhD at the same centre or what, and then just realised it wasn't working?
I realised it wasn't working when they said you can't have any funding after a year of self-funding, and then you're not getting any money after that. So but it was good. I turned my work into some interesting articles later on. I came out of it like, crap, I've got to get a real job. And luckily managed to get a couple of weeks work experience at the Telegraph, and then Daily Telegraph, UK newspaper. And I managed to not cock that up, basically. And
congratulations.
Thank you very much. One of my proudest achievements. And then, over the next several years, tried to slowly steer my career towards writing about sciencey things, and have successfully done that more and more. The more I can write opinion-y, feature-y things about science, the happier I've been generally. And as for writing about Bayes in particular, I mean, I don't know if you ever used to read Ben Goldacre's columns back in the day, Bad Science.
Not the columns. That was, I grew up in Germany, so that was that one. But then when I started my bachelor's in 2010, one of my flatmates really loved Ben Goldacre. So then I read Bad Science about Pharma, and we even went to one of his like talks or something like that.
Yeah. So I think that was probably where I first became aware of Bayes' theorem, him writing about exactly stuff we were talking about, medical tests, this not applying in the same way you think they do, and people getting confused by that. And that was super interesting. And just by nature of being somewhat more mathematically inclined than most journalists, i.e. being able to multiply one number by another, with a calculator. Yeah, well, I mean, yes. That made me the guy who understood stats a bit. And I just was interested in it. So, but like doing things like asking questions, what is the denominator here, puts you above a lot of journalists in terms of asking these sort of questions. But then a lot of where I got really interested in the Bayes side of things, I don't know if you were aware of a guy called Scott Alexander, who's
you quote him in your book, right?
I do, yes.
Yeah.
He's actually a psychiatrist in the US, but he's just a really fascinating blogger and part of the sort of wider community of nerds called the Rationalist community, who my first book was about, which was originally called The AI Does Not Hate You, but is now The Rationalist Guide to the Galaxy for the paperback. And that was all. And they are very much about the Bayesian worldview. And when you want to think about people thinking Bayesianism is a cult, there's a good place to start. They're not. I would say they're not, but you can see why people think they are sometimes. Yeah. But they're very much, the idea like that Bayes can describe the brain, Bayes' decision theory, Bayes' E.T. Janes and all that sort of business. That was all, I was picking up all that stuff. Now, God, this is amazing. This one simple equation that describes so much. And that was when I got interested. And then the reason I ended up writing this book, because I've written now 3 books. All 3 of them have at least a chapter on Bayes in them because of this obsession I've developed. But the second book it came out during COVID. Very good timing. But it had a chapter on Bayes, which
smart decision.
Yes, exactly. Really clever of me to start that pandemic, to cause that leak in that Wuhan virology lab. But yeah, the chapter on Bayes, the Observer, British newspaper, asked me to turn that into a feature for them. I did. The editor who put it together just completely like reasonably to my without really thinking about it said, because it was just sort of how this one equation that you never heard of or something, how this simple equation explains so much of the world, whatever. And he called it this obscure theorem in the subhead, and people went mental. They went absolutely mental. There were days and days of people, it's obscure. Like, I'm a professor of biostatistics and I use Bayes all the time. So, of course you do. Like you go out on the street and ask 90% of people, they won't know, they won't know who it is, anything about it. And I suppose it is a bit, as theorems go, it's not that obscure, but nonetheless, I didn't think it was. Anyway, either way, I thought it was a bit of a crazy storm. People got incredibly upset about it. And so I
guess it's like one of those famous, non-famous things, right? There's some things that are like huge within a community, but somehow just haven't gone beyond it.
Exactly that. Anyway, so and I can see the point. I just got annoyed by the incredible hyperventilating about it. So I went to my agent, and literally within 2 days, I looked back at the emails. Within 2 days of this kicking off, I'd pitched a book about Bayes to my editor and to the agent and editor. And so that's why. But this book is born completely of spite. That's where it's come from.
I think that's the best kind of motivation.
Yes, exactly. Destroying your enemies. What's that? To hear the lamentation.
But I mean, it's not really
women.
Destroying them, right? It's just, no. I mean, in a way, you're helping them. You're like, hey, I wrote this entire book about this thing you like.
Yeah, exactly. No, you're right. In fact, so yes, comforting your enemies and yeah. But yeah, so and you're right. That makes it even less obscure. Hopefully, there will be people saying, I now know all about Bayes. So yeah, so that's how I ended up where I am, writing books about Bayes.
Yeah, why did you... One thing I found kind of interesting when I saw just the timeline kind of your career is that it seemed like you worked as a journalist for... So where was it? Was it the Daily Telegraph?
Daily Telegraph, then BuzzFeed, and then...
Yeah, so it seemed to me that was like until like 15, and then you started working for something like that, like more like online kind of publications, and you started publishing books and that kind of stuff. I'm just curious, was that like an intentional thing? Or why was it just kind of just coincidence that at some point you decided, I think I want to write books now? Or
so it was a bit of a coincidence. So what happened is 2015, BuzzFeed asked me to join them, so I went and joined them, and that was just BuzzFeed was very much the up and coming thing at the time, and it was cool and interesting. And the Telegraph was having a bit of a bad time, and to be honest, still is. So I was happy to get out of there. But then in 2018, BuzzFeed had massively overextended itself and started to do some redundancies, and I'd just been offered this book contract for the first book, and I realized there was no way in hell I was going to be able to write it on a full-time job. So I said, I will take your undisclosed sum of money and I will go away and I'll write this book. And it worked out. And then it's a bit unnerving to go freelance, but when you've got an actual project and a lump of money to go away and do it, it was less unnerving. So I did that, and that was fine.
But you mentioned earlier you have children. Did you already have children then?
I did, yeah. That was 2018. So I had.
I guess that increases the pressure a bit, right?
It does. But then also by then I'd been a journalist for 10, 11 years. So I knew enough people in the industry with people to write for. So it wasn't as bad as it could have been. There were people that I could write, for a while I wrote for Unheard and still occasionally pop up for them. And that was easy because I knew the editor of it who I'd worked with before. And I say, look, I'm quite good at this. Would you like a piece? And they would say, yes. So
you basically had enough experience and
contacts
and skills, presumably.
Yeah, exactly.
That you knew the worst case was not that low.
Yeah, exactly. It was very demonstrable that I could do the thing I wanted to do, that I was claiming to be able to do, which is why it's really hard at the beginning, because you say you might be the best writer in the world, but no one knows. And they've got, especially for a daily newspaper or something like that, they're like, I've got a big hole in my paper tomorrow if you don't file on time or if it's rubbish. I don't you. So if you know that, so if you've worked with someone and you know that they will get me clean copy, making a good point to length. You ask for 800 words, they file about 800 words, and they'll get it to you by deadline at 5 p.m. I remember getting an email from my editor at the time, just because someone had let her down, and she was like, she emailed saying, "Can you write me this piece?" And I was like, "Yeah, what time do you want it?" She said, "That's what a proper fucking journalist says. What time do you want it? Not what day do you want it?"
Right.
So I was quite tempted to find that email and print it off. I remember that really fondly. So that was less scary. It was scary, but it was less scary than it would have been I'd found myself in struggling for work early on in the career, and that had been difficult. But this was, I'll be fine. I knew I'd be fine.
Yeah. Okay. And what's the? So what is it now? You mainly write the books?
No. So I should say I've got a day job for a US media outlet called Semaphore, which set up by my old boss at BuzzFeed, and so he was New York Times. He's a guy called Ben Smith. He went from BuzzFeed to being New York Times media columnist, but now he set up a new website. It's very much news focused called Semaphore, Semafor, with another guy called Smith, Justin Smith, no relation, who used to work. I think he's going to be annoyed with me if I get this wrong, but it would be he worked at The Economist and Bloomberg and ran their sort of financial operations on that side of stuff. So these sort of two quite big hitters of US journalism, kind of set up this thing, and they asked me to come and write their daily newsletter. That's my day job. That keeps me ticking over, and then I wrote the book in the background of that, and I've got this podcast with Stuart Ritchie, our mutual acquaintance, Stuart Ritchie. We do a podcast together called The Studies Show. So that's plenty. I'm thinking about pitching another book, but it's a lot of work, and I don't know when I'll find the time.
Okay, it's just because I think your book came out in every 2 years or something. The 3 books, I think. So it seemed almost like it was oh, this is what you do now.
Yeah, I should, and the second one was written with my cousin, and we do think we have got an idea for another one together, but I don't know when I'll find the time. So I'm keen to do it, but I'm oh God, I should, but evenings are pretty full, that sort of stuff.
Okay. But that was kind of what I was curious about, because for me, I obviously checked out kind of what you were doing, but it was never quite from an outside perspective, it was never quite clear what is this a full-time thing you're doing, or is this just a small thing you're doing, and the books are the main thing, or kind of what?
No, the main day job is a classic journalism job, and then the books, if there are any more, and the podcast that fitted into time around it.
I see. Okay. Should I do the recurring questions?
Let's go for it.
Okay. So at the end of each episode, I ask my guests the same 3 recurring questions. The first is, what's a book or paper you think more people should read? This can be famous or completely unknown. It can be old or new, just something you think more people should read.
So not necessarily non-fiction, or
whatever you want. Just a reading recommendation.
Ooh, I've managed to find some novels recently that I've really just enjoyed, and I'm going to recommend a novel. I think the one I'm going to recommend is Piranesi by Susanna Black.
Okay.
If do you ever heard of Jonathan Strange and Mr. Norrell?
No.
No. Okay. So Susanna Black wrote this book about Jonathan Strange and Mr. Norrell, which it's big and chunky, and it's this strange otherworldly book about it's set in England of the early 19th century, but it's just established that wizards are real in that world, but they sort of haven't happened for anything. So it's a wonderful eerie, strange, somewhat it's unsettling book, but it's very long. But she also wrote this other much shorter book that I read recently called Piranesi, which Piranesi.
I'll put it in the description, the proper title and everything. Yeah.
And again, it's essentially about this guy who in a I can't begin to do it justice, but again, it's strange and unworldly, and there's something going on. You don't know what it is. And slowly, that's all pieced together, and you learn this. Anyway, so that was I loved. It was one of those books that I just ate up too quickly, and I was really like I wanted it to carry on. So Piranesi by Susanna Black, that'd be my one.
Okay, good. Second question is something you wish you'd learned sooner. This can be personal, private, whatever you want, but something you think, if I'd learned that a little bit sooner, then probably would have helped. And if you want or can, also like maybe how you learned it or what you did about it, or
Yeah, that's a big and difficult question. So I'll try not to be too glib. There's all sort of stuff I dance like nobody's watching type things.
Believe in yourself.
Yeah, exactly.
I mean, if you whatever. I mean,
no. I'm trying to think of what I think there are lots of things that would be appropriate answers to this. So give me 30 seconds and I'll think.
Okay. I'll shorten the pause to 25 seconds.
yeah, very sensible. Okay, so the big skill that journalists need to learn, and this is going to sound so basic, right? Pick up the phone, like phone people. Like actually, it's really and it is now. It is such a basic thing. I find some academic's number online. I'm just gonna pester this guy. Like if they don't want to answer or they're busy, that's fine. Because with academia in particular and journalism, the time scales are so different. I used to joke about it being like mayflies trying to understand continental drift. I would email an academic and say, "Can I speak to you for this piece I'm writing?" And 3 months later, I get someone get in touch and say, "I'm actually a bit busy this year, but I can speak to you in 2026." And I wrote that piece. I finished that piece later that afternoon. I've actually forgotten what we were talking about. So I saw it a lot with young journalists when I was getting later in my career, and for me when I was starting out, just phoning press offices was unnerving. But it's not scary. It is important. Learn to be good at just like phoning people up, asking them questions. That's so crucial to a journalist. Also, I never had shorthand, but I can type really fast, and make sure that you can take down these notes quickly. That was something really useful. But I think don't be afraid to just phone people up. It took me a few years because of my strange route into journalism to be able to get really comfortable with it, and now it feels like a superpower.
Yeah, just so before I forget it, one thing I found funny when you mentioned the different timelines between academia and journalism, I think when I mailed you, I think you responded 2 days later apologizing that you weren't quicker. And I was like, you were quicker than most people who responded to me.
Yeah. So that's the thing. I mean, journalism has hours timeline. Most of this magazine is different. But academia it seems like things happen over months and years. It's exhausting.
Yeah, I mean, it takes, up to years to write a paper, right? I mean, to actually do the whole thing. Yeah. Phoning is a weird one where, I understand how it can seem scary, and especially because I guess you just don't know or what state they're in or what's going on. Or
well, I think also nowadays people. Such an old man shouts at clouds thing, but I get the impression now just phoning someone out of the blue is almost a bit rude. Normally, like people text to say, "Is it all right if I call?" and stuff, which is obviously
one thing I find interesting is that my sister's 6 years younger than me, and she basically started studying again basically when she's a little bit older, not like super old, but like mid-20s or whatever, right? Yeah. Anyway, so her friends are then often 20 or 21 or something like that, and she said every time they want to order food or something and they have to call for whatever reason, she always has to do it. And because just somehow even that 5-year difference or something seems to because I guess just not used to it at all, whereas she had some sort of use of it.
I do remember a young journalist when I was at BuzzFeed. So I mean, she'd probably be 30 odd now, but like the landline rang on her desk and she just like stared at it. You're supposed that might be something important. There might be someone with a story. You should probably answer that. Like, just completely, I don't know what to do with this. It was fascinating. It was really fascinating.
Yeah. A final phone comment from me here is that I just started a postdoc in Zurich, and we don't actually have phones in our office.
Really?
Like and it's annoying because I need to call someone recently, and I was like, well, like there's no phone in our office. Like, where is it? It's like, oh yeah, we got rid of them.
Yeah.
So there's one phone on the floor, like in the middle of the hallway or something.
That's weird. It used to have them on every desk, and it was just
yeah, exactly. That's what I'm used to too. But it's probably just because now people have mobile phones anyway or whatever.
Yeah.
And
it makes sense. But if I want to phone the US, I don't want to do it on my own personal mobile.
Exactly. Yeah. Anyway,
not.
Final question. Yeah, so usually this question is like advice for PhD students or postdocs, people in that kind of transitionary period. I don't know how, most of the people I interview are in the academic system, so I don't know how much you can comment to that specific one, but you can take it a bit more metaphorically if you want.
Okay. Well, I would say I did start a PhD, and my one advice would be make sure you want to do it. The reason I started the PhD was because I was scared of the wider world. Like I was good at university, and I was good at my master's, and I didn't know what I wanted to do with my career, really, beyond vaguely be a journalist, but I didn't know how you did that, and I didn't know what I was supposed to do. And it's just staying in academia seemed like the easy course, I
think that's a pretty common, yeah.
Yeah, exactly. And I actually don't... Make sure you've got some question you want to answer. There are too many people with PhDs and not enough places for people to get to... This is my impression. Anyway, there are a lot of people with PhDs these days and not that many places for them to work afterwards. Getting a place on tenure track is tricky. So if there's some question you really want to answer, brilliant. Go and do the PhD. Actually, I think the world will be better or I will be better, be happier if I've answered this question. The world will gain from it. Brilliant. If it's just, I don't know what else to do and a PhD is there and I'm comfortable at university, be wary of that because it might be that at some point you're probably going to have to take the bold step out into the world anyway, because it might well be there aren't enough postdocs or tenure track positions in universities going around. There's a lot. And so that's my bit of advice. Make damn sure you want to do the PhD before you start the PhD. I think that because I didn't, and I don't regret it, but I had to get out of it.
I mean, that's basically my question. Would you still recommend people try it anyway and see whether it works? Or is that because I guess you did it for a year or what?
I did it for a year. It was fine. But basically I was being bankrolled by my parents for that year, right? So not most people couldn't do that. It wasn't particularly a wise use of family funds anyway, but
okay, but like let's assume like you have a scholarship or a position or something like that, and you to try it out, would you still think, or would you say basically like, yeah,
I'd be careful of it. I'd be wary of it because I mean, I imagine most of your listeners will be science in science, whereas I was philosophy. Maybe not all, but
no, that's true. Yeah.
It was very lonely actually. It was just me sitting around in a library. I don't want to put people off, but that was, and this was 20 years ago this year. So things may have changed, but I think the fundamental reality of a lot of philosophy PhDs is that they are a guy sitting in a library or reading on the internet, and
that is very different.
Yeah, that was quite lonely. Whereas I think science PhDs are much more, you go out and you're on a team, you're titrating things together or whatever, I mean, it
can still be, I think, a lot more lonely than people think when they enter it, but okay, that's definitely a big difference.
Yeah, exactly. So basically the only people I saw were my housemates. Some other people on a related PhD course would go for drinks sometimes, but we wouldn't be working together. And I see my supervisor once every 2 weeks or however many, every so often. And it was a bit like, I'm basically, it was the mid 2000s. YouTube had just become a thing, and it was very difficult. You just end up sitting sadly watching early YouTube videos of plane crashes, and I should be doing some work, and I'm not doing any, and I'm just a bit lonely. So that I would say that is a risk. I don't want to put people off academia because I think academia is important and good, but I do think there is a certain sort of person, and I was that sort of person for whom it was a sort of comfort blanket, and you don't actually know what it is you want, and I'll keep doing that because I'm bright, and university keeps telling me that I'm good at university, so I guess I'll just stick with university. But actually, you could use the same skills that you've just developed in your however long at university to do things in the world which will firstly earn you more money, and secondly build more skills, and thirdly probably have a clearer career path. So be very confident. Just try and be confident that academia and a PhD is the actual thing you want, and it's not just sticking on the route that you were already on and inertia is carrying you forward. I think that would be my advice.
Okay, yeah, and I guess to add to that is that if people try something else, like journalism or whatever, and then realize it's not for them, the PhD program is still going to be there.
Yeah, you can always come back. I do think sometimes I would like to go back, and having now done a bit of work as a journalist over the last 15 years, I could go back and do that ethics of science journalism PhD, and it would be a bit more informed. I'd know what I was talking about instead of just making stuff up. And so that would be, yeah. Don't be afraid to go out into the real world for a bit if you're not sure that the PhD is exactly the thing.
Yeah, I think that's perfect advice for academics. Don't be afraid to go out occasionally.
Yeah, exactly. It's cold and scary and there are wolves, but you'll learn things, you know.
Okay, thank you very much.
That's all right.